Okay, we are going to do 2.4, but we're only going to do the first part. We're going to do writing linear equations. Then later, tomorrow we'll take a look at graphing them. Okay, so we're writing linear equations. Remember, linear equation is going to have two things multiply, it will not have two variables multiply, something like that, or two variables multiplied in a way that gives you a exponent or a root, what a linear equation will look like. And stuff like that, where you have addition, multiplication, division of a variable and a number, but not two variables. Okay, so you're used to slope-intercept form, and it's very important that you know the difference in the forms. Slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. Well, where does slope-intercept form come from? It comes from slope and intercept, but it can also come from point slope form. And while I'll rarely have you write in point slope form, it is really important that you know point slope form, because normally you will want to start there in order to get your final answer. So your final answer won't be in point slope form most often, but it's easy to start here, at least quite often. This is where m is obviously still your slope, and then you have a point, hence point slope form, your point x1. Okay, and so that is just a point. So what should happen is you fill in this, but you leave your variable. So it might look something like this. If your slope was 3, and in this case your point would be 2, 7, because it's subtraction. Okay, so write equation slope-intercept form. Well, here we need our slope and we need our intercept. So let's find our intercept. 1, 2, 3. That one's is it 3.75? I'm not really sure. And we don't want to guess. We don't want to be inaccurate. Normally, if you're sure, if it goes straight through a line, that's great. We'll use it. I don't really know. Let's look at slope. Let's see if we can find that. I'm going to use these 2 points and rise and run. I rose 1 and ran 3, but it was left, so it was a -3. So our slope is rise over run 1 over -3, or -1. Now, I don't know, we don't know the intercept. We can guess it's about 3. I'm going to say about 3.75, or it looks like it's in there, but we don't have to guess because we know a point. Pick a point. We could have picked that point we used, or this one. I'm going to use this one because it's positive. That is 2, 3. And so I'm going to use this slope and this point and put it in point slope form, and then transfer that to slope intercept form. So remember, point slope form is going to look like this, where this is x1, y1. So I'm going to plug in. We're going to distribute and solve for y. And once we distribute, now when you distribute, make sure you distribute the slope to that x1. So it's going to be plus 2/3. When we distribute and solve for y, get y by itself, then we have it in slope intercept. So I'm going to add 3 over. So I get 2/3 plus 3, which I'm going to call it 3 2/3. You could, of course, convert that to a improper fraction. This is a mixed number, is easier to see on a graph. 3 2/3, which is 3.6 repeating. I was off, so it's a good thing we didn't use that. Use what you know, and we knew without a doubt it went through this point, and so it was our answer. Now, like I said, if it went somewhere through here, okay, that's great. You can calculate the slope, and then you can just add it to the intersection, like this one. So pause the video, work this one, and then check. Okay, so slope intercept form has a slope, has an intercept. This is the form. I can find my intercept right away here. It's a 3. And I know my slope. I counted 2 and 6. It's negative. It's a negative 2/6 or a negative 1/3. Plugged it in, and there's my slope-intercept form. Point slope, we just talked about that. So we have our point and we have our slope. So now let's practice using that a little bit more, because this time I don't have a picture. I don't have my graph, but I can write the equation just the same. And remember, you should be showing me work on every single problem. Okay. My point here is x1, y1. So y minus a negative 2 equals negative 3/5 x minus 5. So both of them are subtraction. I plugged in my point, plugged in my slope, but it says write it in slope-intercept form. This is point slope, so I have to solve for y. So I want you to pause the video, distribute, solve for y, and then come back. So distributed by negative 3/5 and a negative 3/5 times a negative 5, those cancel but not the negative. So I get 3, subtracted 2, and I get my answer as a negative 3/5 x plus 1. And then I trust that you could graph that. We've already practiced that. It would go through 1, and then you would rise 3 and run 5, one of those being negative. So maybe rise a negative 3 and run 5. So I trust that you could graph that. I would like for you to work this one by yourself. Make sure your answer is in slope-intercept form. So go ahead and pause this, work it, and then come back and answer it. Okay, so I plugged in my x1, y1. Honestly, the hard part about this is just making sure you're careful with negatives and plug the y and the x in the right spot. So just be careful and take your time. I plugged that in, I distributed. Yes, you need to use fractions, right? Unless it's in a specific context word problem where a decimal makes more sense, you need to give slope as a fraction. And plus, especially here, like this is a repeating decimal, so if you just put 0.7, that is not the right answer. So stick with the fractions, use your calculators, and we get y equals 2/3 x plus 1. When you're solving a problem for an equation in slope-intercept form, does that mean you have to start in slope-intercept form? No. Most often, unless you are already given the slope and the intercept, you want to start in point slope form and then manipulate it to end up in slope-intercept form. And I know it's kind of confusing because both names have slope, but they tell you what it is. Point slope has a point in it and a slope in it. Slope-intercept has a slope in it and then the y-intercept. Okay, parallel and perpendicular lines. Two lines are parallel. Now notice this says not vertical. We'll talk about that in a second. Two lines are parallel. Remember, that means they run alongside each other forever and they never intersect. They're the same distance apart. So they're parallel if they have the same slope. This should be a review of at least geometry, if not Algebra 1 as well. Of course, granted, the writing equations was as well. They have the same slope. Okay. Any two vertical lines are going to be parallel. Remember the parallel. Any two vertical lines are parallel. The reason we say vertical lines have, like, we exclude that in this part, they can't have the same slope because they're undefined slope. But obviously that means two horizontal lines would be parallel, but that's because they do have the same slope. They both have a slope of 0. Okay, so for perpendicular, it's the same thing, except it says the product of the slopes is -1. So that would be like 2 and a -1/2. If I multiply those together, I get -1. So 2 and -1/2, maybe 3 and -1/3, maybe 2/3. And how I would get -1 there is -3/2. So maybe you've picked up on the pattern, or you remember that for perpendicular equations, their slopes are opposite or reciprocals. So opposite meaning they need to have opposite signs. One's positive, one's negative. Reciprocal meaning you flip the fraction. So 2/1, the reciprocal is 1/2. Now, again, the hardest part here is making sure you're careful about negatives and everything. Write an equation in slope-intercept form for a line that passes through 3, -2, and is perpendicular to the line whose equation is, and it gives us the equation. Perpendicular, so remember they're going to be the slopes are going to be opposite reciprocals. So the slope from the original is -5. You will not use that. That does not matter. All that matters in the original equation is the slope. And so now my new slope, or the slope I'm using, is going to be the opposite reciprocal of that. So instead of 5, I have 1/5, and that was negative, so mine's a positive. Once you've gotten this new slope, you don't need any of this. And I would get rid of it. Like, don't let that old slope confuse you. That's what I need. I have a point, I have a slope. I'm going to plug it into point slope, and then eventually get it into slope intercept form, because I have to make sure I actually answer the question by putting it in the form ask. Okay, so I have y plus 2 equals 1/5 x minus 3. And then I distribute my 1/5. So yeah, it's not real pretty, but that's okay. You can totally do it. And we're going to subtract 2. And you are welcome to use your calculator, but we can do this. -3/5 and a -2 is going to give me a -2 3/5. And like I said, you can do that in a decimal. I told you couldn't do slope in decimal. You can do this in a decimal if it's not repeating or not irrational. I do recommend, though, that you give me a mixed number, but improper is okay. So the key thing here is if it's pull only the slope from this equation. If it says perpendicular, it's opposite reciprocal. If it says parallel, it's the same. I want you to pause and work this problem and then check back. Okay, so perpendicular, remember this is a symbol for perpendicular, so they're going to be opposite reciprocals. My slope here was 3, and now I'm done with that. My new slope is -1/3, plugged in my point slope and solved, and that is my equation. Now, it says write an equation for the line, and it didn't tell you what form. If it doesn't tell you what form, assume it's slope intercept. Okay, so unless it tells you otherwise, always put it in slope intercept. Now, I could check this by graphing, and we're going to focus more on graphing, like I said, in the second part of this section. And you can check it by graphing, but you should always, if it says to write an equation, you should do the algebra to actually find it, and then check by graphing. Never find it by graphing. Before you finish, I want you to write the equation for a parallel line. So let's pretend this, rework this exact same problem, but I want it to say parallel. And remember, that's the symbol for parallel. Pause it and check that. Okay, so this slope was 3. This is parallel, so it's going to have the same slope. So it's 3 plugged in. Notice right here that this equation, this equation and this equation are no different other than the slope, as they should be, because they're going through the same points. Their two slopes you can see are opposite reciprocals, as they should be, because this is parallel to that and that's perpendicular. So if it's perpendicular to that, it's perpendicular to this. Okay, wonderful. You have homework and a daily over this tomorrow. Email me with any questions.